So in the last video, we introduced rate of change, average rate of change, and we looked at tables and graphs. Well, what if we have functions and formulas? That's what this is going to look like. So let's spend some time and calculate these. Example 3. Find the average rate of change of this function f of x equals x squared minus 1 over x on the interval from positive 2 to positive 4. It sounded like I was going to keep talking, but that's the end. So we're going to start with our formula. The average rate of change is always going to be f of the second x minus the function value at the first x divided by the second x minus the first x. So now we just have to figure out what all of these things are. So just like in the last video, the first x is 2. The second x is 4. So let's replace everything. The first x, right? Or the second x, right? That's x2. x2 is 4. So just plug that in. x2 becomes 4 minus f of x1, which is 2, divided by the second x minus the first x. So the bottom, we can simplify the bottom. No problem. The top, we have to know what is f of 4. So we're going to go off to the side and say, I don't know f of 4, but I'm familiar with section 3.1, and I can find out what f of 4 is. So f of 4 is just this function. Replace all the x's with 4's. 4 squared minus 1 over 4. That's 16 minus a fourth. That's 15 3/4. Great. Do the same thing for 2. Plug in 2. 2 squared minus 1/2. That's 4 minus a half. That's 3.5. So just like before, f of 4 is equal to 15.75. So let's replace it. 15.75 minus 3.5 divided by 4 minus 2, which is just 2. Subtract this out. It's okay if you use a calculator, and you should get 12.25. I think. If I do my math wrong in my head, you let me know, all right? And then 12.25 divided by 2 is going to be 6.125. This is the average rate of change on this function. All right. Let's do another problem somewhere. Example 4. Why not? Whoa. Oh no, I set this up perfectly, but I forgot. The words are already there. So this is example, this is example 4, where we have the electrostatic force F. Let's call the electrostatic force F in newtons, how we measure force in metric system, between two charged particles can be related by the distance between them, d. So here's our two variables, output, F, input, d. D is given in centimeters by the following formula. F of d equals 2 divided by that distance squared. The force is 2 divided by the distance squared, where d is the distance between the particles. So find the average rate of change of force if the distance increases from 2 to 6 centimeters. These are distances, inputs. This is our first input. This is our second input. All right. You can use x's. D's would be better here, but you can use either one. All right. I'm going to switch them to d's because our input variable, our independent variable, is d. So this is d1, and this is d2. So normally the average rate of change, right? Normally, if we go off to the side, it's this. But we don't have x's and y's here. We don't have x's and little f's. We have distances and forces. So let's update it. Average rate of change is the force at the second distance minus the force at the first distance divided by the difference between these distances. And again, you could use these variables as well, but this is what it actually is. You'll get the right answer with this, but this is better. Okay, so again, we know that D1 is 2 centimeters. So replace all the D1s with 2's. D2 is 6. D1 is 2. So just replace them. Just like so. And then we're going to have to go off to the side like before and say, well, what is the force when the distance between the two particles is 6? This is the rule. Replace D with 6. That's 2 over 6 squared. It's 2 over 36. That's 1 over 18. And do the same thing. When the distance is 2 centimeters, the force is going to be 2 over 2 squared. That's 2/4, or 1/2. So this is f of 2, plug it in. This is f of 6, plug it in. F of 6, oops, I erased too many things. F of 6 is 1 over 18. F of 2 was 1/2. Denominator is 4. You might have to use a calculator here or do something else to kind of do what we do, grab here. But either way, that's going to be 1/18 minus 9/18. I'll write that out. All right, 1/2 is 9/18. That's going to give us negative 8/18 over 4, which reduces down to negative 4/9 over 4. When you write out negative 4/9 over 4, it's actually going to simplify down to negative 1 over 9. Went through that kind of quickly, but you can let me know if you have any simplification questions as well. Okay, so that is example number 4. Let's do one more. Oh, I missed the units. The units on the top, these are forces, right? The force is in newtons. And again, whenever you have units, you include them. Like in this one, we didn't have any units, so we didn't include them. This one we do. Units on top, that's force, right? F in newtons. Units on the bottom, these are distances. Distance are given in centimeters. So this is going to be negative 1/9 newtons per centimeter. So what this means, I can't draw an N. That's better, I guess. Is that as the distance increases from 2 to 6 centimeters, on average, we lose 1/9 of a newton with every centimeter that we go, on average. All right, and that's a very important thing right there, interpreting this as well. Let's do one more problem in this video. Example 5. Find the average rate of change of this function, g of t, equals t squared plus 3t plus 1 on the interval from 0 to a. So it doesn't have to be a number, but the process is the same. This is still our first x value. This is still our second x value. The average rate of change is still the function value. Oh, all right, we're using different letters again. We're not using x's, right? We're using t's. It's still the function. The function now is g at the second input minus the function value at the first input, right? This is the change in outputs. Functions give outputs. Change in outputs divided by the change of inputs. Well, T2 is equal to A. I'm supposed to circle that. T2 is equal to A, so replace the T2 with A. T1 is equal to 0. Replace T1 with 0. and do the same thing on the bottom. And now we simplify. What is g of a? This goes back to 3.1. G of a says, look at g. Replace all the t's with a's. A squared plus 3a plus 1. That's g of a. How do we find g of 0? Replace all the t's with 0. G of 0 is 0 squared plus 3 times 0 plus 1. That's 0 plus 0 plus 1. G of 0 is just equal to 1. So let's replace g of a with what it equals, and g of 0 with what it equals. So g of a is a squared plus 3a plus 1 minus g of 0, which is 1. Be very careful when you're subtracting these. Parentheses are usually a good idea. Here it doesn't matter though. Divided by a minus 0, which is just a. So we're adding 1 and we're subtracting 1. Those cancel out. We're just left with a squared plus 3a divided by a. But this isn't fully simplified. As long as a doesn't equal 0, we can factor and cancel. We factor an a out of the top, becomes a plus 3. Right? We can check our answer. A times a is a squared. A times 3 is 3a. The denominator is still a, and now the a's cancel. So as long as a is not equal to 0, this average rate of change is a plus 3. The reason why we have to specify it is because the domain of this function and the domain of this function are not the same. Right? We covered in 3.2, the domain of this function is everything except when the denominator is equal to 0. Everything except for 0. Whereas the domain of this function, there's no problems. It could be anything. So we want these things to be the same thing, and that's why we have to specify this is only true when a is not 0. Okay? So we should probably include that whole thing in our answer right here. Like so. That's the average rate of change here. And I do another problem, more complicated version of example 5 in the next video.